Hi everyone, today I'm here to discuss another project. So in this we have two parts. We have to run the pre-coded, like the code that has already been coded, and then we have to answer some of the questions. So in first we have to import the necessary packages and libraries like Quise, NumPy, Skippy, SkyImage.color, Matplotlib, Pilot, import request, and then import bytes.io. So our first method is to import the image. To get the image from, like, how we can get the image from the URL. So the method that we use is request.get. This will help us to get the image. Now we have to visualize the content of the response. To visualize, we have to print it. Print response.content, whatever the content we have to give the response for. And next step is that we have bytes buffers the image into RAM. Image.open opens the buffer. Okay, these are the methods that will help us to run. So first we have to input image_array, np_array image open. This will help us to give the numpy array of the image. First let's see the image. To run the image we have to use the IAMShow, which is the method which will help us to display the image from the array. Now we have to print the array shape. To do that we have to use the print the name of the image dot shape, and then when we have to compare the values of color channels 0 and 1, then we have to use a 0 and 1 here. And then if we want to compare the values of color channels from 1 and 2, then it's the same method, just we have to change the 1 and 2 here. So it will give you the result. Now we have to save the color channel 0 into the input, then print it. Then to save and then print, we use the same thing, which is channel is 0, and then we have to print, right? So we are using IAMShow to print the image, so it will give you the exact result. And then visualize the values inside of the resulting array. So for to visualize we have to use the same method. Now next moving to is convolution with 2D kernels. Create a padded array by adding 2 rows and 2 columns. To get a padded array we use padded array equal to np.pad, and this will help us to add and one of each another of each at the end. Now we have to create the kernel. For the kernel we use np_array, and this will give you the result. This will help us to create the kernel. Create an output of the array filled with zeros, so we are using the output_array, and it will help us to display the image shape. Compare both arrays. Now we have to compare the original and the padded array, so we are just printing the original array shape and it will help us to compare. Now apply to the array values. Now we have to apply the kernel to the values of the array. We are running a loop for I in range padded array this, for j in range this. We are taking a temporary array equal to padded array, and then output array is np.sum. Now we are displaying the result of the array the same way output, like we are outputting the result. So this will help us to give the result in gray, right? Define a function to scratch out the values between 0 to 55 range. So now we are defining a squash pixel value. If value is 0, return 0, else if this, return value, else return to 55. Define a function to apply a convert 2D kernel to an image. So with this we have to define the same thing, and then we are running the image. 9 detection. Now we have to create a kernel to detect horizontal lines. To detect the horizontal lines we are implementing horizontal kernel, and then we are applying the kernel to the image, and then we are plotting the result of the image, right? Sorry. So now we have to, based on the coordinate represented on the above image, create a coordinate to detect 45-degree lines using